Hello everyone, we're looking at the Pythagorean Theorem. As you saw in the video yesterday in class, we had the formula. We introduced it in the video, and the formula for the Pythagorean Theorem is a squared plus b squared is equal to c squared. We're going to show the proof of that in just a few minutes, but before we do, I want to talk to you about some vocabulary words that you need to remember. So the legs of a right triangle are the sides that are connected to the 90-degree angle. So this is the 90-degree angle right here. It's always shown to you as a square. And you have to have a right triangle for the Pythagorean theorem to work. So, of course, the right triangle means that one side has a 90-degree angle. So the legs are, here's the leg, they're connected to the 90-degree angle. You see that? So these two are your legs, okay? Of course, this longest side is called the hypotenuse. So it's not the leg, it's the hypotenuse. So we have the longest side here. And that is the hypotenuse. So hypotenuse. Okay. And that's your hypotenuse right there. Hypotenuse is kind of parallel to the 90-degree angle. So the leg is connected to the 90-degree angle, and the hypotenuse is parallel to it. Hypotenuse is the longest side. So always remember, hypotenuse is the longest side length. Okay. Now, typically what we label these as A, B, and C. So hypotenuse is always labeled as C, and the legs are labeled as A and B. Now, what's important is that you can label this leg B or A. It doesn't matter. Okay, so it doesn't have to be that the leg that's, I don't know, vertical is A and the leg that's horizontal is B. That's not necessarily the case at all. So the A and the B can be interchanged, but C is always the longest side. So be careful with that. C is always your hypotenuse. Okay, so A squared plus B squared is equal to C squared is the relationship between the two legs and the hypotenuse of a triangle, of a right triangle. So very important that it's a right triangle. Okay, so one of the angles is 90 degrees. So that's how you show a 90-degree angle, by having a little square here. Now, you could have your 90-degree angles could also look like, I don't know, this. So it doesn't have to be in that specific shape, right? It could look like that, right triangle, sorry. And in different situations, you'll see different scenarios. So it doesn't always have to be exactly looking like this, but it does have to have a 90-degree angle. And that will ultimately indicate that you have a right triangle. Okay, so A squared plus B squared is equal to C squared. That means that you guys are familiar with when you square a number, right? That means that you have A times A. So if you have the length of the side of this side, you square it, so you multiply it by itself. And then you take the B and you multiply it by itself. That's B squared. And that is ultimately equal to the hypotenuse squared, which is C times C. And from that formula, we're able to figure out what C is. So let's talk about the proof of this. So kind of see, why is this relationship true? Why is A squared plus B squared equal to C squared? Well, in the video from yesterday, we saw this, that where we were seeing that we were showing the relationship between the side lengths and the hypotenuse, and that each side length, like for example, this side here is 1, 2, 3, 4. This is a 4, right? This length is 4, but the area of this square that is connected to this length is 16. So that's where this comes from. So even though b is equal to 4, right, b squared is 16. And we could see that because an area of a square with the side length of 4 is 4 times 4. You could count how many squares you see. It's 1, 2, 3, 4. And if I count all the way up, I'll get 16 in this entire blue square. If you look at this bottom piece, this other leg, you see that the side length here is 3, but the area of this entire square is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And of course, that's where A is 3, and 3 times 3 is 9. So that's the area of this square. And if I count all these here, I'll get 16, right? Okay. Now, we know that 9 plus 16 is 25. Where is that 25 coming from? Well, that 25 is this square. So we can see 1, 2, 3, 4, 5. In fact, here, this came out to be a nice round number. So the length of the hypotenuse for this triangle is 5. And if I count, 5 times 5 is 25. And that's the area of this square. And you could see that if I took all these pieces inside this square and this square, they would add up to 25, which is what this is saying. 9 plus 16 is 25. So if you square all the side lengths here, you will, when you add them up, you get the side length of the hypotenuse. And that is what the proof of the Pythagorean theorem. And this always happens with a right triangle. It doesn't matter what size of a right triangle you have. It doesn't matter what shape of a right triangle you have. You will always have this relationship. So this here is going to show you a 4 by 3 by 5 right triangle. And it's pretty neat to see that relationship. Okay, so from here, we're able to actually solve for C, because if I wanted, so there's no 5 here, right? We know from the measurements of these squares that this length is 5. But how can you mathematically show that? Well, 9 comes from 3 squared, right? And 16 comes from 4 squared. Well, what comes from 25? And that's 5 squared, right? So, in fact, we know that 4 squared and 3 squared. You could write that down. So, our C is 5. Now, a better way to do this would be when you see that at the end you have 25 is equal to C squared, because you're not always going to have a nice round number like this. In order to solve for C, which what we want is C. We want the side length, so we just want C. See, this 5 here is C. This 4 here is A. And this 3 here is B. Okay? We're going to be given the A and the B. We want to figure out what C is, but when we solve it, at the end, what we have to do to figure out what C is square root C squared. When you square root C squared, you'll get C. And we established this last week when we talked about this. So we said that if you square root, remember this when we say square root 9 squared is 9, right? What happens with that? That the square and the square root cancels out and get that number. Well, here with a variable it does the same thing. So when you square a square root, those two cancel out to get C by itself. Well, what you do on one side, you got to do the other, right? So if c squared is being square rooted, then 25 needs to get square rooted. And therefore, you get 5. And c is equal to 5. So that's a easier way to do this rather than to, I'm going to go backwards, which was what I did because we had a visual here. So, but what you want to do is always make sure that you know how to mathematically solve something, especially when it comes to the Pythagorean theorem, because you always need to know how to square root and do that for sure. So your calculators are going to come in handy because there are a lot of times where you're going to not have a nice rounded number like 5 as your answer. So you will need to utilize your calculators for these a lot. So you'll see me do that as well. Okay, very good. Let me just clean this up a little bit because I changed the color on it, and there we go. Okay. So C is 5. All right, so let's go to the next question here and see if we can solve one. So here we have a right triangle. We know it's a right triangle because it's got a little square right here, right? And that indicates that it's a right triangle. We can use the Pythagorean theorem to solve for this length. This length is the hypotenuse, which we'll call C. Let's just go ahead and keep everything the same and call this A and call this B. So we're going to use A squared plus, remember, B squared. Those are the two legs. The two legs are connected to the 90-degree angle always, is equal to C squared. So we'll take the 4, that's our A, and square it. Add it to 7 squared, right? And that's equal to C squared. Okay, go ahead and solve for C squared, you guys. And just solve for C squared. What do you get when you do that? We'll be right back. Okay, so we're going to go ahead and get this. 4 squared is 16, not 8. Remember, 4 squared is 16. 4 times 4. 7 squared is 49, not 14. Please be careful. And so 16 plus 49 is 65. Okay, so C squared is 65. Now remember what we talked about before. We want C. We don't want C squared. C squared is what the length of the attached square is. That big piece of that square that's connected to it. We want C. We want the side length of that square. So what we do is we square root. And what we do on one side, we got to do the other side. So we're going to square root. This will give us C. Remember, the square root of a square cancels itself out. And here what you're going to get is when you, in your calculator, hit 65 and then the square root button, and you'll get 8.062, and then it keeps going because that's an irrational number, right? And so you guys remember irrational numbers. So it keeps going and it does not repeat. So with that, what you're going to do is you're going to round this to the nearest tenth. Okay, so round it. And that's what we did today for warm-ups. Round to the nearest tenths, which means that I'm going to look at the hundredths, right? And if this is 5 or more, I'll round this up, right? So I need to round it up because it's a 6. So 8.0 rounded up is 1, and there we go. 8.1 is C. So I can just write that in there. Now I know that some people even write square root of 65 as the answer because it's more precise, but we can just round our answers to the nearest tenth. And if you'll see ever that you have to round it to the nearest hundredths, then you would just look at the thousand spot and round that. So the nearest hundredths, this would be 8.06, but nearest tenths would be round to the nearest tenths is 8.1. Okay. So I'd like you guys to go ahead and look at problem number 2. use the Pythagorean theorem to solve it. As you can see, again, you have two legs here that you're given, so we're going to stick with the legs this time. And you can label them A or B, it doesn't matter, and solve for C. Go ahead and solve this on your own, please. We'll be right back. Here we go, problem number 2. Hopefully you labeled the legs of this triangle. 3 would be A, 2 would be B. It doesn't matter. You could call 3B and 2A. It doesn't matter once again. But the hypotenuse is C, so that is the longest leg. So be very careful about that. Always label C correctly. A squared plus B squared is equal to C squared, so that means 3 squared plus 2 squared is equal to C squared. Went ahead and solved that and got square root of 13 is equal to C squared. Square root both sides. Well, that's what I meant. 13 is equal to C squared, and we square rooted both sides. And C became 3.605. Be careful with this. So we're rounding to nearest tenths again. And so we're not looking at 5, right? Because that's, if I wanted to round to nearest hundreds, we're looking at the 0 here. And since 0 does not round the previous number up, we just keep the 6 as it is. If this, instead of 0, I had a 5 or any number above 5, then the 6 would turn into a 7. But since I have 0 here, or if I had 4 and any number below 4, the 6 would stay. So 3.6 is your final answer. Go round to nearest tenths. Be careful with rounding, please. Some people I know that are kind of rusty on rounding, and it's difficult for them. So if you're having trouble with it, please practice through the tutorial that we have and the practice link that we have, or ask us and we will help you out. Okay, we'll go ahead and do some practice problems next. Have a great rest of the day.